Hello everybody and welcome to another C++ tutorial for beginners. Now in today's video, I'm going to be discussing a topic called references. Now a reference is really an alias, so another name for a variable, and allows you to modify the variable through its reference or through its alias. Now people get confused with references and pointers and all these other kind of complicated things that are relatively specific to C++ and C and these kind of lower level languages. So anyways, I'm going to do my best to explain this to you. With that said, let's dive in. So as I said, a reference is an alias, otherwise known as another name for a variable. Now to create a reference, what you do is initialize a variable just like you normally would. So you say something like int a equals, let's say 2. And then if I wanted to make a reference to a, I would say int ampersand, which is above the 7 on your keyboard, and then whatever the name of the reference is that you want, and then is equal to, and then that variable. So notice we have the same type. The only difference here is that we have this ampersand, and what this tells us is B is a reference of A. Now, really what that means is that if we modify B, we will also modify A. And the reason for that is B is not storing a copy of the variable or the value, that is stored by A. It is telling us where A is and is giving us access to the variable A. Now, this is going to be a little bit confusing, so just bear with me. I'm going to have to probably explain it a few times before you guys really get it. But again, the idea is this is an alias, just another name for a variable. We do not have two separate values here. We don't have A being equal to 2 and B being equal to 2. We have B being equal to A and A being equal to 2. Now, let me just show you what I mean here. If I see out A and I see out end L, oh, not end LF, just end L, and then I see out B and then end L, you're going to see that both of these are equal to, if this loads, 2. All right. Now what happens though, if I change A and I make A equal to 3, notice I haven't changed B, right? I'm just changing A. Let's see what happens now. Well, I need to add a semicolon so it doesn't crash. When we add a semicolon, we can see that both A and B changed. Now, same thing here. If I change instead of A, but I change B, so I make B equal to 4, and then I run this, you're going to see that both A and both B changed. Now, this is different if I remove this reference. So if I change this reference now, and instead of saying int reference B is equal to A, I'm saying int B is equal to A, what you're going to see is that A does not change when I change B. So if you look at this here, you can see that we have two different values, 2 and 4, and same thing in the opposite direction. So if I change A to be equal to 4, that does not change the value of B. The reason for that is when you say something like int B is equal to A, really what this is saying is make a copy of whatever the value A is storing and store that in the variable B. So if we're looking at our computer here, we kind of have two little boxes. One box labeled A that stores the value 2, and then another box labeled B that stores the value 2. These are two distinct value 2s. And therefore, if I change A to be something else, that doesn't change B because B is pointing to a different version of the number 2 than A was pointing to. However, if I make this a reference and I say, okay, B is now referencing A, what that means is there is only one box in our computer that has the value 2, and B is simply pointing to that box. So A, when I do this, say we set up this little box here and it has a 2 inside of it, and then when I say the reference of B is equal to A, really what this does, I'm trying to find an arrow here, is it just points this variable here to be equal to this same box. And so when I do something like A is equal to 4, that changes the value in this box to 4. So now when I access B, I'm accessing 4, right? Because B is pointing to whatever box A is kind of holding or storing. So hopefully that analogy or visualization kind of gives you a bit of intuition into how this works, but that is a reference. Now, some of you may be asking me, well, what is the point of a reference? Well, to be honest with you, it's hard to really show you the point of a reference right now because we don't have any functions and we haven't learned about more advanced things in C++. But a lot of times you don't want to just know the actual value that a variable is storing. You want to actually have access to that variable, and you want to be able to change that variable, but through another name. So like I showed you here, now we have this name B, which is really the same thing as A. It's just another name for A. And now if I modify B, this changes A. And that's a good thing. That allows us to be a bit more flexible in our program. And again, I apologize because I can't give you a really good example right now, but there is a lot of situations really when you get into functions where you want to have a reference to a value so that you can actually modify that value. You don't have to, just use a copy of that. So hopefully that's kind of clear, but that's the basics of references. Now, of course, you can make a reference of a reference. So if I say something like int, and then we say ampersand C is equal to, and we make this equal to B. Now, if I say C out, and I C out C, and then I end L, you're going to see if I change C to be equal to 2 here, or I guess I should change to something else, make it equal to 3, then now all of these values change to 3. So when I say int ampersand C is equal to B, what this is doing is again giving me a reference to A. Now, this is where it gets a little bit more confusing, but essentially we have this ampersand B, and this is telling us B is a reference. However, whenever we access B, we just use the value B here, this actually gives us A. Now, I know this is weird, but when you see just like a B sitting here, really what this is giving us is whatever this is referencing. So it's giving us A. And so when I say int ampersand C, so the reference C is equal to B, it's really giving me the reference to A. It's not giving me a reference to B, which is then referencing A. It's giving me a reference to A. That is why if I change C, it changes both B and A, because same thing here, there's one box in our computer and all 3 of these variables are pointing to that box. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is AlgoExpert. AlgoExpert is the best platform to use for preparing for your software engineering coding interviews. They have over 150 coding interview questions on the platform, many of which are taught by me. With that said, check out AlgoExpert from the link in the description and use the code TechWithTim for a discount on the platform. All right, so hopefully that's clear. Now, the last thing I want to show you here is how you actually access the address that these references are pointing to. Now, unfortunately, I don't have any good drawing stuff in front of me, so I could do a little illustration for you guys because that would probably be helpful. But the idea here is that when you say B is equal to A, like I kind of showed you, really B is just pointing to that box that is storing the value 2. Now, whatever the value 2 is in, that box, I'm just going to keep calling it a box, has a location. That location is in your computer's memory, it's in RAM, and it has some identifier for it. And you can actually look at what the identifier or kind of the address of a variable is by using the ampersand sign in a different kind of context or different way. So I'm going to erase all of this, actually all of these references, and we'll just keep A. And now what I'm going to do is show you how we can look at the address for this variable. So if you put an ampersand before a value or before a variable, this actually tells you the memory location address of this variable. So let me show you. If I run this, notice we get this kind of random gibberish that doesn't mean anything to us. This is actually a hexadecimal memory location that is telling us where the value 2 is stored. And so when you put the ampersand, instead of giving you the value stored by the variable, it's giving you the address. So that's what the address is for A. Now, if I do int and then ampersand B is equal to A, and then we just copy this line and we do the same thing and we look at B, let's see what we get. Notice that we get the exact same thing. The reason we get the exact same thing is because this is a reference, right? B is pointing to A. And so B has the same memory location as A does. And that means if you modify B, you're modifying A. If you modify A, you're modifying B. However, if I say int B is equal to A, and now I do this, notice that both of these are different, right? And the reason they're different again is because what's happening is it's creating a copy of the value 2, storing that somewhere else. And now we have 2 different memory locations, one for B and one for A. So hopefully that helped you clear it up a little bit. But again, remember the syntax here is you use the ampersand before the variable when you're accessing it. If you want the memory location, there's not too many times when you actually want to do that, but for some reason, if you do want to do that, I mean, that's how you access it. And then if you want to create a reference, you just declare a variable exactly like you would before, except you add the ampersand beforehand. So of course, I've been showing you everything with ints just because it's the simplest. You can do this with string, you can do this with bool, you can do this with whatever else you want. So if I say something like bool x is equal to true, and then I say bool and then ampersand y is equal to x. We can replace this location with x and with y. Let me get rid of both a and b here. Let's print this out and notice we get the same thing, right? This works with all other variables, not just ints like I was showing you. Okay, so the last thing here is just kind of some nuances and details about references and creating them. So when you create a reference, you must initialize it. What that means is that when you write bool, and whatever the name of your reference is, or the type and whatever the name of your reference is, you must have an equal sign after, and you must set it equal to actually reference a variable. You cannot do something like this. You can't say bool ampersand y. Now, this would work if you said bool y because you're saying, okay, I'm initializing this kind of empty variable called y that is of type boolean, and then you can change it later on, or you're declaring this boolean variable y, and then you'll initialize it later on. But when we're talking about a reference, you must initialize it when you declare it. And I know I kind of use those words interchangeably. That's slightly inaccurate. Technically, the declaration of a variable is defining its name and type, while the initialization is actually giving it a value. So anyways, just remember that whenever you create a reference, you must give it a value immediately. You must initialize it. You can't just do something like int ampersand y. And in fact, if you try to do that, you're going to see we get an error, right? Declared as a reference, but not initialized. Now, I'll show you something else. You also cannot make this equal to null. So in C++, there's this thing called null. We haven't really gone over it, but this is kind of what you can use as a placeholder when something just doesn't exist. There's nothing there. And anyways, if I do this, you're going to see we get an error. It cannot bind non-constant value, reference of type bool ampersand to an R value of type bool. So just another note there, you cannot initialize the value as null. It must be initialized to a variable that is the same type as the reference that you defined. Okay, so one last thing to mention here is whenever you define the type of your reference, it must be the type of the variable in which this reference is referencing. So if I try to do something like string x is equal to, and then I say make this equal to hello, and then I try to reference this here, you're going to see that we do get an error, invalid initialization of reference, because x is a string and, well, this is a bool. So just keep that in mind. You need to make sure the types are actually matching. Okay, with that said, I think that's all I need to cover here. Again, this really isn't too confusing if you can kind of have that visualization of those boxes, right? And think about what is this variable actually pointing to? Because then if you change the location that it's pointing to, anything else that's pointing to that location, well, that will have a different value as well. Anyways, I hope you guys enjoyed. If you did, make sure to leave a like, subscribe to the channel. I will see you in another YouTube video.